Okay, are we ready? No, yes, we are. Yes, we are. All right. Math journals out, please. We've got some vocabulary I want us to write down because we've been working with. Yeah, vocabulary. Math has vocabulary too. It's good. It's good vocabulary, and I want to take notice of the poster on our board in front of us. So find an empty blank page in your math journal. And think about what we've been working with. We've been working with decomposing fractions, right? And that's kind of confusing. So I want us to think about what the term decomposing means. How do you know what that means? It's a big word. And then I want us to take a look at what each of these fractions mean, because they're not all just fractions, you know, so that. Oh, hey, see, that's a vocab word, you know that. Yeah, but these are different types of fractions that we can see. So we've got proper fractions, improper fractions, and then mixed numbers. And there's different ways we can break them apart, and we've been playing with that a little bit. But I want this to be in our math journal, so if we forget what any of these mean, we can go back and look at it, okay? Yes, sir.
Well, I guess we can use this proper function and improper function.
Right, because they look the exact same, right?
Oh, I think I know. That makes sense.
It does make sense. It's confusing. That's why we're writing it down, right? But let's take a look. We're gonna write these definitions and I'll write it up there because I know it's a little small and hard to see. But a proper fraction, notice that the numerator is less than the denominator. Because what happens if they're equal to one another? It's one whole, correct? Yeah, I'm gonna write it down in a second. So just wanna wait for one moment. We'll write it down, okay? Now let's look at our improper fractions. What do we notice about our two numbers here? Very good, Sebastian. And this means not only is it greater than one, but that means it's an improper fraction. Now with our mixed number, you've got one whole number, so see how there's the big three, and then a fraction next to it. But we can turn our mixed number into an improper fraction. So we're gonna write all this down so that we can take a look at it. And I'm also gonna have us keep our poster up for the time that we're working with decomposing fractions, because I think this stuff is confusing, so I think it's important to talk about. So find a blank page in your math journal, and I want us to title this Decomposing Fractions. Okay. Now the first vocabulary word that's not on the poster, but I think is important for us to understand is decompose. So let's write decompose. So we've been practicing this, but can anyone make a guess of what decompose might mean? Do you know? Breaking down or breaking apart. Very good. So breaking down. Or breaking apart. And that could be fractions. We've also heard decompose when we were in garden. Remember how we talked about decomposers, correct? So there's different ways, Anthony, set up please. There is different ways that we can see decompose within our real life. So that is very good. All right, so let's just go through what's on the poster and then write it down. So our first one is our proper fraction. Now, what did we just talk about? We said that the numerator is less than the denominator. And with our example, we can use the example that's on the poster, right? We know that 3/4 is a proper fraction because the 3 is less than 4. And if you also notice on the poster up there, I broke down 3/4 in that box as 1/4 plus 1/4 plus 1/4. That's how you decompose that fraction to make it into smaller pieces. So let's draw that. Okay, so we'll draw a box. How do we make fourths in this box? What do we put in the lines?
Oh,
Like almost like a window, right? Yeah, so one line down and one line across. That now is fourths. To represent 3/4, we're gonna color in 3 of those boxes, leaving one uncolored.
mhm.
And then next to it, I want you guys to write 1/4 plus 1/4 plus 1/4. And that equals our proper fraction.
Mhm.
Anthony, are you writing this down? Or do you know if you want it? All right, now let's talk about our improper fraction. We're all writing it like that. What? Same. Yeah, improper fraction. And the definition, like we just talked about, is numerator is equal to or greater than the denominator. But what did we just establish? If the numerator is equal to the denominator, what does that mean?
Oh, it's 1/4.
It's 1/4. So you guys can write that down if you want. You could say 9/9 equals 1, just as a reminder, because it's always good to remind yourself of things, especially as we're learning it. For our other example, which is on the poster, is 9/2. Since 9 is greater than 2, we know that is called an improper fraction. It's also good to look at the root, right? We talked about roots. IM or IN means not. So we see that this is a proper fraction. M is not proper. So it's just the opposite. Yes, we are. Good job. If you guys do want to write that out or draw that out, you can. But I want to take note of that equation that I wrote next to it. There's a way that we can make our improper fractions into our mixed numbers. Do you guys remember how we talked about that?
Wait, are we gonna put mixed up?
We are, but first we're going to talk about how to turn an improper fraction into a mixed number. Because that's also important as we go throughout adding, subtracting, and decomposing our fractions. So does anyone remember what we did, our trick to figuring out how to create a mixed fraction from an improper fraction? It's okay if you don't. We briefly talked about it on Tuesdays. It's been a day. Okay, so if we're looking at 9/2, I want you to think of this like a division problem, okay? So I want you to almost act like we're dividing 2 into 9. So you can write it like this. Yeah. So if you look, go out to the side, 2 divided by 9. You guys know your 2's, so I know you guys are gonna be great with this one. But how many times does 2 go into 9? 4. So you can write your 4 on top. And then, I know this is standard algebra, but I'll follow through. 9 minus 8 is 1. So that's our remainder, right? Now, looking at this problem, we see that 4 is gonna be our whole number, and we're gonna write 4. And then our remainder is 1, so it's gonna be 1/2 left over. And that's how you make a mixed number from an improper fraction.
You divide.
You divide. Let's do another one, for example. Okay, it's tricky. This is tricky stuff. It's okay if you don't get it. Yeah. So let's try another example. And we'll have more examples as we work throughout our lesson today. But let's say we're looking at 12/5, okay? 12/5. 6, no. So let's think. Write it out. 5 divided by 12. How many times does 5 go into 12? 2. Good, Diego. We know 5 times 2 is 10. 10 minus 12 is 2. So whatever number's on the top of our division problem is our whole number. Our remainder is our numerator, and our denominator stays the same.
I got it.
You get it now? Good. Into what? We haven't even started the lesson yet. We're just writing vocabulary. Any questions there? Are we ready to write about our mixed number?
Yes.
Yeah, we are. Turn the page if you need to. All right, friends, our mixed number. Oh, sorry. Yeah, no, mixed number. But it's called a mixed number because it is a whole number and a fraction. Sure. But make sure you're taking notes that make sense to you, right? You don't want to look at it and be like, I don't remember what that said, because I do that sometimes and I'm like, uh-oh, I gotta go back and read what I wrote, or yeah. So a mixed number is a whole number and a fraction part. Our example up there is 3 and 2/5. Draw it if you would like to. It's up to you. Well, let's think about when we decompose, right? We can decompose it in a couple ways. We could separate the 3 and then do a plus sign 2/5. And we kind of saw that at the end of our lesson on Tuesday. Right? We can also decompose it into a 2 plus 1 plus 2/5. It's like adding, yeah, but it's all equaling the same thing. We're just making each piece a little smaller and a little smaller and a little smaller. Remember what we said one whole was?
5/5.
Yes, Levi. 2 plus 5/5 plus 2/5. You could technically keep going, but we're gonna stop right there. We don't need to keep decomposing.
Okay.
We're just breaking it apart. So look how I broke apart the 3 and the 2/5. So I know it looks like we're adding, but we're not. The plus sign, treat it like a,
Add the 3 to.
right, treat it almost like a relationship. They're connected, but it's just splitting them apart. And then I split the 3 again into 2 and 1. Plus the 2/5. And then I broke it down to a fraction. They're not getting it close. Okay, so we talked about how we can make our, Levi, Sebastian. We talked about how we can make our mixed number, or not, excuse me, our improper fraction into a mixed number. Now we can make our mixed number into an improper fraction. Crazy. Yeah. Yeah. So do you guys remember how we did that? We talked about that on Tuesday too. Levi, don't push up with that. Your head. Leave it on the ground. Let's think about it. Let's look at our 3 and 2/5. Yep. Do you guys remember how we broke it down into a improper fraction?
No.
Oh, no, wait, we just did it, but we're doing it in reverse. So now we're doing mixed number into a proper fraction. Well, let's look. I'll show you. No practice. What you do first is you multiply the numerator and the whole number.
And then add the numerator.
Yeah. So 3 times 5 is 15. Then you add the 15 plus 2, 17. So our mix or our improper fraction, see, it's hard to remember all these names. Is, yes, 17.
Oh, that's so
Nice. Easy, right? That's a really great tool, especially as we're adding and subtracting mixed numbers and fractions. Because it's hard to do. That's what we're going to be kind of doing today. Okay? Questions about any of this?
No.
Oh, I love that. Do you guys want to practice one more of these? We'll have plenty of practice today. Okay. So don't put this away yet. We're gonna need to use it for workspace. Yeah, just put it off to the side. You can close it, but if you close it, maybe put a Post-it or a piece of paper to mark your spot. All right. Find your math workbooks, please. And we're turning to page 55. And we're gonna do a little warm up of subtracting some fractions.
Oh, because of the
So let's look at it. It says, let's add and subtract fractions and analyze our strategies. Warm up. Subtract some 8s. So notice each fraction has 8s in it. And I want you to try to find these answers mentally. So do your best. Might not be the perfect answers, and that's okay. I'm not looking for perfect answers. I'm looking for you to find ways to work through this. Okay. Oh, tricky. No. I want everybody to start working on it and just do your best. No, mentally. So writing your answers down next to it. And think about ways you're getting to your answers. Okay?
Can we go back into it?
You can.
Yeah.
No Syrian math. No extra comments, you guys were working independently, and we should not be talking if you're working mentally. Because for me, mentally is you're doing the answers or you're working through the answers in your brain.
Yes.
Yeah, you're not showing your work, you're not doing anything else, you're trying to think about it. Yeah. Yeah, Sammy, let's try at least the first one, please. Thank you. Be quiet for one more minute. How are we doing? Did we try the first one? Try the first one. Let's try it. Look at it and try it. Please. Okay. I'm letting everybody work through. Mila's back there working so good quietly. Voice. Remember what we talked about on Monday or Tuesday? Oh, I don't want you guys to just wait for the answers and wait and watch. I don't, I'm just saying this in a general statement.
Okay. Oh, you have no.
And I love that you tried. It doesn't have to be right, but I want you to try to work through it in your brain and on your own before just waiting for me to show you your answers, because that's how you're gonna learn. And if you make a mistake, that's okay. We go back and we fix it, right? You can be patient. All right, everybody, take a big deep breath in. Patience is good. I love that you guys are working through it, but. Okay, I even like the question mark that Bria wrote next to it. That means she's gonna wait and check her answer. Good job. Okay, Levi, number 1. How did you get that? What did you do? Right. Or even if you're looking at it, you guys know when you're subtracting the same thing, what does it do? It makes it 0 or it erases it. So we are looking at our numerator or our fractions. They're both 3/8. So we can cross those out. Left over is 2. So not too crazy a math there. That was pretty good. Mila, did you end up finding the second one? 2 and 2/8. Is it? Let's think about that. Okay, let's think about it. Here you go. Thank you. Stop, please. So I like where you went there, but let's take a look here. Look at our fractions. Let's analyze or look at our numerators. Is 3 less than or greater than 5? I'm asking you. Less than. And remember what happens when we subtract a smaller number from a bigger number?
We get mine and we get.
I was asking you that, but he answered for you. Thanks, Levi. So it becomes a negative number, right? And that doesn't help us with fraction. That doesn't do anything for us. So we can't exactly subtract 5 and 3. What we need to do is figure out how to break this apart. And you could do it different ways. You can decompose it. Leah, move away from Levi, please. Or we can turn it into our improper fraction like we just talked about. So let's do 2 times 8. 2 times 8?
16.
And then plus 3.
19.
19, right? So 19/8. And see how we could do that mentally still? We don't need to exactly write it down. So now we've got 19/8 minus 5/8. Since our denominators are the same, we're subtracting our numerators. So what's 19 minus 5?
14. No, wait. 14. 14.
14/8, right? Okay. Now, how do we turn it back into a mixed number? We just talked about it.
Oh, yeah, you go.
What do? Remember, from mixed number to improper fraction, or sorry, improper fraction to mixed number, what do we do with the denominator and the numerator? Look at your notes. Find your notes. Look at your notes. It's in your notes. Yeah, please move away from Levi. Levi, please. Look at your notes. Look at your notes. Everybody. Thank you, Sammy. what do we do? How do we turn our improper fraction into our mixed number? We just wrote it down in our notes. Almost. What's the opposite of multiply?
Add.
Divide. So we divide our denominator by our numerator. So 8 divided by 14. How many times does 8 go into 14? One. Good, Maria. Now we've got 8 minus 14. What is that? It's 9, 10, 11, 12, 13, 14, 6. So our number is,
1 and 16.
good, Anthony, 1 and 6/8.
Yeah, so good.
I know that wasn't exactly mentally, but that's how you kind of work through it. I know, it's hard. I would not be able to do it mentally, that's for sure. Okay. Number 3. Anthony, did you get number 3? What'd you get? 3/8. And how did you get that? Yeah, so we saw that the whole numbers were 2s. 2 minus 2 is 0. Cross them out. What's our answer? 3/8. All right. Number 4, Leah. Close.
4/8.
It's 4/8.
Yes.
Yeah. And how did we get that? There you go, Leah. Enough. Hey, I can't hear Anthony. If you guys can't stop talking, I'm gonna make you go sit in separate places, okay? So, let's all listen to Anthony, because he's gonna share how he got the answer. Go ahead. Yeah. Okay, so what did you do first? Do you have an idea? Can you help try to explain it? If not, that's okay. Did you break them apart in your brain at all? Yeah, you broke them apart. How did you break them apart? Did you break apart the whole numbers and the fractions? And then you just did all that? So let's do it in this by using this method that we did before. Let's turn our mixed numbers into improper fractions. So looking at that, we know we already did 2 and 3/8. So we can know that 2 and 3/8 is 19/8. Well, we did it up here, remember?
Oh.
We already did it. You gotta use your resources. We already did that one, so I don't have to think about that one. But let's do this one. 1 and 8, 7/8. 1 times 8 is 8, thank you. Plus 7. 8 plus 7 is 15. Now we've got 19/8 minus 15/8.
14/8.
14.
4.
4.
Oh, not bad. I was going to erase the 1. I was looking at the top. All you have to do.
So our answer is 4/8. Look at it. Do we need to change it to a mixed number?
No.
Why? You're right. You're right. You said no. Why don't we have to?
Oh.
Because it's already a proper fraction, and that's the simplest, or close to the simplest as we can get. You were close. Good job. That was super close. Yeah. All right, turn the page, please. Here you go. Let's read the instructions, please. Thank you. Levi, can you please move to that table right there? Yep. But not right next to Leah, where Noah usually sits. Please, let's go. No? Okay, so like Diego said, we're going to find the number that makes the equation true. So notice that we've got some blanks in our equations. Now, I'm gonna be honest, this one's pretty tricky, so let's try to work together to figure these out. All right, so yeah, Anthony, do you want to share with what you did for the first one? 5, 6, and why did you, or how did you get that?
So I looked at the other fraction that was added,
Yeah.
and then so I took up 5, 6, and then I just split the 2 into like 2 ones, and added 5, 6 as 1 equals 6, 6, and then that makes it already a whole, and then plus another one is 1.
Great, thank you. So what he was doing was he looked at the number we are adding, and he looked at the answer. Now we know we need one whole with one left over. What makes a whole number again? Remind me. 6, 6, 7, 7, right?
If
It has to be the same.
Equal to the denominator.
Correct, yes. So Anthony knew that one whole is 6, 6, right? But we also needed one left over, so we don't need just 6. We need one extra. Right, so we have 2 6 is what we're adding on to. If we added, let's say, 4 6, that would just equal 6 6 for 1, right? So he knew that we needed one extra, Christopher. So he thought since 4 6 plus 2 6 equals 6 6, what's 1 greater than 4? 5, right? So 5 plus 2 is 7. The denominators stay the same,
7, 6.
7 6. Now, if we turn that into a mixed number,
1, 2,
it's
1,
1, 1 6, right? And that's what we were looking for our answer, right? Now let's take a look at the second one. And let's take a look at the second one. And I want you to try this on your own. I know, it's hard, but let's look. We've got our first number, and we've got our answer.
So we already know the denominator stays the same.
Yep, so good, that's a great observation. We know our denominator has to be 5, right? And we know we're adding, that helps a little bit. So we know we've got a whole number of 2, and we've got a whole number of 7 to finish. So let's see what we can do. Try, we'll come back together, but let's try. Yes, I love it. Well, let's try. Just take a moment and think about it. Again, remember, if it's not right, that's okay.
I don't get it. I don't get it.
That's great. That's a good way to think about it. But make sure that we know what we're looking for. We know we're looking for 7 and 3 fifths. What is it? 7 and 1 fifth, right? So that's what we know what we're looking for. What can we do to get there? This needs to be correct and huge. Oh, makes sense. Daniela? You don't know? Okay. I told you guys this was gonna be tricky today. But I'm just forcing you to try and think about it. Because it's good. Well, you guys do know, that's not true. You guys do know. You've been doing really well. Okay. I like our thought process that you guys are doing. I do like it. I see a lot of us has our whole number as 5 in this blank. Now, why do we not want it to be 5 exactly? Let's think about that.
Because it's a line in the
Right. But we need to have a fraction, and we need to have 1 fifth left over, correct? So we can't exactly put 5 because we might go over 7. right? So maybe let's try with 4, right? 4, okay? So let's say our whole number is 4. Now, what can we do to our fractions to get 1/5 and 1? So, like Sebastian said, 5/5 is 1 whole. Look how close 4/5 is to 1
You
whole.
just need one,
Right. However, we need to add another whole number. So what do we need? We need 1 more to get 5/5.
5, 6.
You're close. You're close. You're so close, Levi. We have 4/5. And like Levi said, we need 1 more there. So we could add 1/5. But that's gonna equal 5/5. Yes, Levi, you're so close. I can tell you're right there. So we're looking for 6/5, right? Because that'll give us our leftover. So what? 4 plus what equals 6? So what could be our fraction? 2/5, right? So let's look. Let's think about this. 4 2/5. So let's take a look at this. I know it's hard. You guys are doing great. 2 plus 4, we know is 6. Okay. If we add 4/5 plus 2/5, we know 4 plus 2 is 6/5, correct? Our whole number is 5/5. So we could break down 6/5, me and Sammy. We could break down 6/5 into 5/5 and 1/5, right? Remember, we're decomposing. We did that in our warm up. And we're doing that, or we did that in our notes. That's how you break it down. We do, because then we have 7. We need 7.
Oh.
Right? We know 5/5 is 1 plus 1/5. We can't forget about that 6/5. 6 plus 1 is 7. Fractions left over 1/5. Our answer is now 7/5 and 1/5. Tricky. Tricky and tricky. How do we feel about that? Kind of good? That's okay. That's okay too. That's all right. This is hard. And that's why all these extra talking and you guys not messing around is not gonna help you. This is hard stuff. And I want you guys to get it down. You gotta do, you were getting. Don't put yourself down like that. You're doing great. Yeah, I know. Well, doing anything with fractions is really hard. So I don't like it. Let's take a look at our next one. Now we have our equation. 3 minus 2 1/3.
Oh.
I know, I love it, Anthony. Let's let everyone think about it. Everyone take 30 seconds and think about it. Do it on your own. Sammy, go sit at your spot.
Can I go to
That's okay. I want you guys just take 30 seconds. Try it on your own. That's how you grow. That's how you get better. Try it on your own. If you get it wrong, that's okay. It's not a test. It's not a grade. Work through it. Think about it. Now raise your hands. Does anyone have ideas of what we can do here, Leah? One third. 1 1/3. That's a great guess. But not quite.
3 minus 2.
Right. That's a great guess. I love that you did that because that's what I would have done too. That's not quite correct. You're close. No? Anybody else have an idea? I'm coming, I know you know. Okay, all right, Anthony, what did we do?
So the answer is 2/3 because I subtracted 3 minus 2 equals 1. And another way to say 1 is 3/3. And 3/3 minus 1/3 equals 2/3.
You guys get that?
No.
I know. He's got the fraction brain over there. We got a little fraction brain over here. So here's what he did. He took his whole numbers just like Leah did. So that's why you were close. 3 minus 2 we know is 1. But that doesn't mean that we're done because we still have 1 minus 1/3. You're close though. You're close. And Anthony knows to make one whole, we need 3/3. So he just decomposed 1 into 3/3. That way he can subtract the fraction. I know. Yeah. So now 3 minus 1 is 2/3.
Okay.
You're not.
You just, because you didn't subtract
The fraction.
yeah,
right?
you did the whole
You
number.
gotta think, like we talked about with the decomposing. This 2 and 1/3 is actually 2 plus 1/3, right? They're not one whole number together. It's two different numbers put together. And even our definition of mixed number, it's a whole number and a fractional part. So it's not one thing altogether, it's a mixed number. So you can't forget that that's separate from one. All right, so similar to B, let's remember what we did here. We've got D, but now, I know, I love it. But now we have our full equation. We're just looking for our answer here, okay? So let's look at our numerators. Remember, that's our first thing we want to do when we have a mixed number and a numerator or a fraction. Look at our numerators, 1 and 5. Can we subtract them? Yeah. 1 minus 5. Can we do that?
But yeah.
We can technically, but why can't we in fractions? It's not forbidden, because we would get a negative fraction. That's nothing. Well, that doesn't mean anything to us, right? So what do we need to do to subtract these easier?
Gotta break the whole numbers to 12.
Yes, yes. Why did you do that? Make it easier to subtract, correct. Now, we do know that. How would we decompose it? What if we did 3, so let's look at this one. 3 plus 1 plus 1/2, or 1/12, right? Like Levi said, 1 is 12/12. So now, it's gonna be a little easier for us to subtract here. That's another way we could have done that. We could have made our fraction into a improper fraction, right? Could have done that. But that's okay. So, next step, what do we do? From what?
4
Or,
or 3 and 12.
so we're just looking at our whole numbers. You're right.
Oh.
3 minus 2 equals 1. Now with our 12/12s, we can add 12/12s and 1/12 together, right? Which is, well, 13. 13/12. Yeah, but this makes it easier to subtract from 5, right? Now it's 13 minus 5. What is that?
Eight.
Eight. Now, putting it together, our answer is 1 and 8/12. Tricky, tricky, tricky. But Levi, you got that. That was great. You did a great job there. You were able to break it down like we wanted to. Now, I'm gonna show you that it might be easier to just, instead of breaking it down like this, might be easier to do this. Right?
Yes.
Where we create an improper fraction from our mixed numbers. So let's take a look at it, see if we get the same answer. We've got 4 and 1/12, so if you guys want to write this down in your notebook, you can, or you can just watch, it's okay. 4 times 12 is what?
48.
48. Plus 1 is 49, so that new fraction is 49/12. And then 2 and 5/12. 12 times 2 is 24 plus 5, 29, okay? So now here are our two new improper fractions. Now this is easier for us to subtract, right? So we've got 49/12 minus 29/12 equals, what's 49 minus 29?
Oh,
20. 20/12. Now how do we make it back to our mixed number? 12 divided by 20. How many times does 12 go to 20?
2.
1 time. So 1. 12 minus 20 is 8. I think that's the same answer, right? Remember, our number on top is our whole number, so 1. Our remainder is our numerator, and our denominator stays the same. Let's check.
Oh, yeah, that's.
Same.
That is the thing.
Is that way easier than this way?
No.
Why?
Yes.
I mean, yeah.
I personally think this way is easier, unless you've got the brain where you can break it apart like
Yeah,
that.
But
But
I don't think I have it.
no, I
I
don't.
do something else because my mind is okay.
No, we're almost done with this.
I don't think we are.
I know this is hard. Let's take a second. Stand up.
Two more pages.
Stand up.
Exercise.
No, we're not. I'll take a look. Stand up. And I want you to stick your wiggles out for 30 seconds. Stand up. You can dance. You can do it sitting. Come on, stand up. Let's go. Stand up. Stand up.
We just have a page. Two more pages.
Okay, ready? Wiggles out in 3, 2, 1. Go. Wiggles. Whatever you need to. Maybe it's roll your shoulders. Maybe it's breathing, stretching like Diego, whatever it is.
Yeah.
Okay, 5,
I don't know how it
4, 3,
That
2,
was 30 seconds.
1. Yeah, you guys stood around for so long. All right.
Yeah, no, 30 seconds. I counted only like.
Sit down. We're back to it. Sit down.
I was counting, that was only 1 second. That's crazy.
Okay. Let's move on. Let's see this page.
What?
Okay. Oh, you did great. We can talk about it later. This is our last page, okay? Now, this is a good way for us to figure out our strategies. Yeah, Sebastian, enough. You okay? Did you hear your funny bone?
When you hit your funny bone, it's not fun. It's not fun.
You know, they call it funny bone because it's funny for everybody around you except for you. I know, so that's kind of neat. Okay,
I believe it.
friends, we just got our wiggles out. You should be quiet. Leah, I need you to sit by Miss Oakley, please. Please. Thank you. I want us to get through this, and I want us to try to understand. I know it's hard, but I want us to try to understand. We're getting there, we're all getting there. And I know it's hard and I know our brains hurt, but we're almost done. This is our last page. And then move on, okay? All right. Let's see, Mia, will you read the instructions for 12.2?
To be composed or not to be composed. Here are some addition and subtraction expressions. So it doesn't become based on whether you think it was helpful to compare a number to find the value of the expression. We prepare the explanatory.
Great. So what we're gonna do is we're gonna look at all of these expressions and we're gonna put them into two different categories. One category is not necessary to decompose, which means we can do the math without needing to change our fraction. Or it'll be helpful. So we're not exactly solving. We're looking at our different equations and we're deciding if it would be easy for us to break it apart, okay? So let's do the first one. We've got 18/5 and 7/5.
No.
Why no? Just no, just no.
Maybe because 18.
You got it. 18/5.
18/5.
Mila, do you want to help them out?
Yeah, you don't need to do all that because 18/5 to take away 7.
Great. We can look at our numerators. 18 is greater than 7. We don't need to worry about doing anything. We could just subtract 18 minus 7, and that'll be our new fraction. Good job, Mila. Thanks for helping. So, which category? Not necessary or necessary?
Not necessary.
We can write A.
And you can color in the website, so
Okay. B. 1/6 plus 9/6. Is it necessary or not? There you
Yes,
go.
yes.
Leo, what do you think?
Nope.
Why? Why? I'm thinking help them out. You said no too. I heard you. Yeah, let's look. Are we subtracting or are we adding? Make sure we're looking at our symbols, right? If we're adding, we don't need to change anything. We can add 1 and 9. It's 10/6, right?
Not
So
necessary.
not necessary. So we can write B.
See?
Ooh, C.
I have no idea. Yeah.
No idea.
Necessary. Necessary.
Right.
Necessary.
What?
Huh?
You're right. It is necessary. But can you tell me why?
Because the whole number and also number, so you can't just subtract 7 minus 1.
Yes, Levi. You're getting it. Good. So like Levi said, we're subtracting. And since we've got a whole number, a fixed number, we can't. Because think about it. Remember our relationship? 1 and 3/8 is technically 1 plus 3/8. But they're connected. We can't separate them from each other. We can't divorce them. They're together forever. Okay, so we're gonna have to change the 7 into a fraction, or we can decompose it into a fraction.
7, 8.
Well, that makes sense.
Oh, 7, 7.
Okay, so C would be necessary.
Yeah, necessary. Oh, the next
None
one.
or number D. 102 100s plus 5 and 27 100s.
No, necessary. 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 Necessary.
Why?
Because it has one and more number and then 7,700 and then it was 100.
Yeah.
If you add it, it will be like. Because 107.
And it could be as easy as making this one into a mixed number. Right. So necessary T. Bria, can you read the equation for E, please? Try it. Just read it. You don't have to solve it. You don't have to answer. 2 and yeah.
Wait, yeah.
Necessary.
Necessary.
Necessary, because it's like the same thing as the last.
I agree. I agree with you. So let's put it down.
Yeah.
Now you guys kind of understanding what to look for as we
I
go
did.
through.
No, I don't.
Okay. Let's look at F.
Oh, it's not.
Yes, it is, Mia. Why do you think? Well, let's look. I can see 2 reasons why it's necessary. Well, 1, we've got a mixed number and a fraction. But 2, looking at the numerators,
Oh.
1 is less than 6. We can't subtract those. Otherwise we'd make a negative number, negative fraction, right? Right, exactly. So we would need to decompose our 6 and 1/10. So necessary.
Oh, I don't, oh yeah, G, I think it might be necessary.
Why?
It probably are necessary.
That's not true. There's a couple more that are not.
Oh, like. Oh, I see one.
Why would you say G or not? Yeah, G is necessary. I agree with you.
Yeah, but you can't do it 8 and 19.
But the reason I would personally decompose it is because 100 is such a big denominator.
Yes.
So we could probably make it smaller, right?
Oh, yeah,
Break it
because
down a
you
little
can
bit more.
decompose it.
We can decompose it,
And 50,
50 or even 10,
25,
25, right?
5,
5, yeah. Great
Two.
multiples.
Two.
Good job. 2. So, yeah, we
One.
could break it down
negative
and make it a little bit easier to do the math, right?
negative 2.
So I'm gonna put G down there too. Look at H.
Necessary.
Why?
Necessary. Oh, because there's just.
Well, there you go. So look for help. I know you can do it.
Dictionary.
H. Look at it. We have a, what is this called?
We have 40.
And a
Fractions.
improper fraction. What can we do to our improper fraction? Make it a,
Mixed number.
and that would be easier, right? We can also make 5 into a fraction or improper fraction.
Because 5 is equal to.
Oh my goodness.
Oh my God. So I would say H as well.
Yes.
Let's look at I.
All necessary.
Not necessary.
Not necessary.
Nothing.
Are you just guessing or do you,
Yeah,
can
I
you
just
tell me?
guessed.
why? Well, you're right, because we're adding again. And I can add
We
Hold
can
on,
add
1 and
that.
3 tenths
We can add
plus
3
6
plus
tenths.
6.
We can do that.
It's just 1 and 10 tenths. Or 2.
What about J?
Not unnecessary.
Oh, wait.
Unnecessary? what you
Necessary.
I said not necessary.
I'm gonna say necessary.
I was gonna say not unnecessary, But I switched up like I needed to say wrong. I said this is it, like I didn't say that wrong.
So, same thing that we've been talking about. We've got an improper fraction and a mixed number. I know I can change that improper fraction into a mixed number, and that would make it easier for us.
Yeah.
Right, I think so. So, J down below. Okay, before we finish, I want you to choose one of the expressions. I don't care which one. Choose one,
Also, it could be.
and you're going to solve it.
Yeah,
Okay?
they want to go with that. I'm gonna choose the easiest one.
Here you go, solve it, solve one. Any of them, solve one.
I know.
Solve it.
How do you, how do you break it?
Cause that's how I was born, I don't know.
Done. I have a friend that's both.
Well, yeah, I'm left-handed, but I can throw and catch right.
What?
But
So you're both? Oh, you're left.
Kinda, but I eat,
I'm
drink, right. With that.
I'm none. I'm
Let me see,
I'm just this one.
solve it.
I'm done. Miss James. Miss James, I'm done.
He did B, which is the easiest one.
That's what I did too.
Can you try to change that into a mixed number? What about what we do there? If you get one, if you did an easy one, I want you to try another one. Yep. Rise, one more.
Hey, do I have to do one more? I did it already.
I did A.
Do one more.
No, you didn't. You did B.
Oh, we did two.
And
Okay, fine.
like I just told Mila, if you've got an improper fraction,
Oh.
can you change it to a mixed number?
Five, six, one. Can I do A? What the heck?
10, 6.
Neither. I did A.
Let me see the answer. Yes, yours and Bruce, she's done 3 already. Diego, Levi.
Oh, I don't get it.
I did it. I already did it.
Around the world.
Don't forget. All right, how are we feeling? Thumbs up, thumbs sideways, thumbs down.
I did two.
Right now, I'm going sideways because I don't.
Right now, in the middle, sideways, and blue.
Okay, middle sideways will be good.
I'm like this. I'm like this.
You just said you were.
I like
You
this.
just said if you're in the middle.
Sideways is okay.
I'm not there.
Is this pretty side for you? I know.
How about this? What do you want?
Okay. Class.
Yes, yes.
Thank you, Mia. Class.
Yes, yes.
You guys can close your math journals and workbooks.
I don't get it. We didn't need the whiteboard.
No, we are going to lunch.
No.
It's not lunchtime yet.
That's our picture.
We're going to do, grab your multiplication division papers to start. Cause we don't have that much time for math rotations, but we can do it. Vegetable. Good job, you guys. So let's do our math, multiplication and division papers, please. And if you're done,